Calculation of valency. This you will need in standard 10, especially when you are trying to write the formulas of compounds. You start it from standard 9 onwards, then you will need it throughout your plus 2 also. So if we are given the atomic number and we know the electronic configuration, we can find the valency of the element. Like the serial numbers, I have given the atomic numbers in the left hand side column, and then name and symbol of the element are here. Then the electronic configuration. Electronic configuration, you know that it is the arrangement of electrons in the various shells K, L, M, N, etc. So let us see how to calculate the valency. The number of electrons in the outermost shell are called the valence electrons. So if we know the number of electrons in the outermost shell of an element, we can calculate the valency of the element. Say hydrogen is having 1 electron in its K shell. Hydrogen is having only 1 electron, and that 1 electron is put in the K shell. So its valency is 1. We have a certain set of rules to find the valency of the elements. If 1, 2, 3 or 4 electrons are there in the valence shells, that is in the outermost shell, if you have 1, 2, 3 or 4 electrons, then valency equals number of valence electrons. For example, if you have 1 electron in the outermost shell, hydrogen is having only 1 electron, and that is in the K shell. So the valency of hydrogen is 1. Then lithium is having electronic configuration 2, 1. It is having 1 electron in its outermost shell. So it is having a valency of 1. Beryllium is having 2 electrons in its outermost shell. So it is having a valency of 2. Like that, if you are considering sodium, 2, 8, 1 is the electronic configuration. Valency of sodium is 1 because the number of outermost electrons, valence electron is 1. So 1, 2, 3 or 4 are the number of electrons in the outermost shell. You have the same valency as the number of valence electrons. The other rule says if you have 5, 6, 7 or 8 electrons in the outermost shell or valence electrons, then valency equals 8 minus number of valence electrons. 8 minus number of valence electrons. Let us see if it is true. Say take chlorine. Chlorine is having 7 electrons in its outermost shell. That means it belongs to that group 5, 6, 7 or 8 electrons. So chlorine is having 7 electrons. So its valency should be 8 minus 1, which is equal to 8 minus 7, which is equal to 1. 7 is the number of electrons in its outermost shell. So 8 minus 7 will give you 1, its valency. Say in the case of sulfur, it is having 2, 8, 6. 6 is the number of valence electrons. So its valency should be 8 minus 6, which is equal to 2. Let us take nitrogen. Nitrogen is having 5 electrons in its outermost shell. So its valency should be 8 minus 5, which is equal to 3. Now where did we get this 8 from? 8 is the maximum number of electrons that can be accommodated in that particular shell. Say for fluorine is having 2, 7 electronic configuration, and those 7 electrons are in the L shell. L shell has a maximum capacity of 8 electrons, and fluorine is having 7 in it. So we can't take 7 as the valency of fluorine, but we will take it as 8 minus 7, which is equal to 1. Now As in every cases, here are also some exceptions. Let us look at a few other elements. Say helium. Helium is having an atomic number of 2. And helium's 2 electrons, those 2 electrons are present in the K shell. And K shell has a capacity of 2 only. It can accommodate only 2 electrons. So, the valency of helium is 0. Helium, as you know, is an inert gas. Let us see if there are others who are having the same valency, that is a valency of 0. 288, that is argon. Argon is having an atomic number of 18. So its electronic configuration is 288. Only 8 electrons or 8 electrons, that is the capacity of the M shell. No more electrons can be added in it. So argon is also having a valency of 0. Who else is there? Let us come to atomic number 10, neon. Neon is having atomic number 10. Its electronic configuration is 2, 8, and only 8 electrons can come in L shell. So its capacity is full. So that is why it is also having a valency of 0. Another anomalous behavior shown is by phosphorus. Phosphorus is having 3 or 5 as its valency. That you will come across many compounds, then you will understand what it is. So, in order to calculate the valency of an element, you have to see how many valence electrons are there in its valence shell. That is, in its outermost shell, how many electrons are there. If the number of electrons is 1 or 2 or 3 or 4, then you can take that number as the valency. Valency will be equal to the number of valence electrons. But if the number of electrons are 5, 6, 7 or 8, then the valency equals 8 minus the number of valence electrons. I hope you understood this.